So you can read it. Just leave it for now.
It's so hot.
You're so hot still wear a long sleeve.
She thought you were wearing a shirt inside.
Wear long sleeve.
That's what she said.
Yeah, I didn't wear anything inside.
I was just here sitting down and then I was here sitting down with her in aircon, and then she came in on the aircon.
I pretended to pick up the pen.
Hi.
Hi.
Okay, wait, let me get the.
Hey, Blossom here to do.
Yeah, let me get the worksheet. Oh, here. Okay, what's it doing over here? Okay, so this was what you all did, okay? 3rd of April, that was 2 weeks ago. Solution, okay, any update like what you're doing now?
Separation technique.
Okay, so Jim is at separation. How about Sarah?
Like,
Oh, you're going to light. Okay, light is a bit tough because yeah, it's physics. And, not everybody is doing that. Okay, how about Rachel? What?
I don't know. Wait, I booked video.
What do you mean? Did you go to school?
I forgot what to say.
Okay, never mind. Okay, how about HD? Solution and suspension. So you see, eventually everyone does the same thing, just different sequence, right? Blossom, what topic are you at?
Light also.
Oh, you're going light, then we might have to do light. Davian?
What?
Science. What science topic?
Let me try to think.
4, 5, 6.
I don't know.
1, 2, 3, 4.
Because of the science teacher, we don't even know what she's talking about. So
What do you mean? Is it like element common mixture? Cannot be, right? Should be finished already.
Usually,
Should be finished already. So now is the part where most of it may split into like different things, right? Some school might be doing physics, some doing chemistry, some do bio. First, okay, so I do not know what is it. You gotta tell me that I can prepare. So it looks like
I don't know, solution, suspension, I'm just anyhow guessing now.
solutions. Okay, never mind. So it should be something there, right? Okay, solution suspension. All right, so what?
60 drops.
Okay, so what we are going to do is
My history teacher said.
Huh? No, which teacher?
History.
Of course, not history.
okay. What I'm going to do today is we actually are going to continue from the the worksheet we did, the math one.
No.
Oh, I didn't put it here.
What was it?
There, the calculation, the timing, and all this stuff.
I didn't come.
Yeah, so we didn't finish this one.
Mama, can you say when the next
I know, but I want to finish this, then we go on.
You finished it.
Are you sure? Did you finish it?
I cannot ask me, huh?
Are you sure you finished it?
We did. Just
You can't ask me.
No, it can't be.
No, we finished it already.
I know Blossom also not here last week, so it's also. Wait.
We finished already.
No, I must ask actually. Actually, you finished it. Never right.
We finished.
Don't listen to them. Usually when they say yes, it means no.
No, he does not.
Did you finish? I don't remember finishing, right? Do you have this? Can you take it out? Can't take it out.
Yeah, I'm taking it out.
Hey, I don't have extra for you. I only have 2. One
I
and
took out.
4. I only have 2.
I took out mine already.
What?
Yeah, sorry.
You took 1, right?
No, I didn't take any. I don't have anyone. I didn't come.
Did I give you?
No, I didn't come.
This one. This for you.
Oh,
Okay. Let me just upload the thing here. Okay. For
This is math.
yeah. We had math class last week.
Why are you asking for time?
Okay.
We had to do
Let me load the thing. Okay.
You know, I haven't even learned speed yet.
Huh?
Yeah, I didn't listen to last year after PSLE.
Yeah, but you gotta do it right now. Alright, give me 1 second.
Challenge history.
Upload the thing. No, last week because Blossom wasn't here, we didn't switch on this thing, so I do not know
Yeah, this
where
is
we
the
stop.
what time is like or something and where
Yeah, right. What number is it? 1.3. Okay, yes. Okay, this is the one. Then the other one is separation. And come on. Where's the
that's
What normal?
Okay, so David, I gave you one. Wait, David, were you here last week? Do you have this? You have right then. Then do you have it? Do you have the worksheet?
I don't know.
Can you take it off? So that we have one extra, then it's for Sarah. Alright, so we were doing this. This is about the physical quantity measurement rate, speed, and density. Just to recap, what is the formula, right? So the first formula that we need to know is, of course, density. So formula for density equals to mass. Density equals to mass divided by volume. Okay, so that's density. What's the SI unit for mass? SI unit for mass? Kilogram. Kilogram. Okay, and the SI unit for volume?
Meter cube.
Oh, very good. Meter cube. So what is the SI unit for density overall?
Kg per meter cube.
Yeah, kg per meter. All right. So then the other formula here, of course, is speed. Speed equals to distance over time.
Oh, yeah, that's correct.
Yeah. So distance is in terms of meters, times is in terms of second, and then all these are SI unit, and therefore speed is in meters per second. Okay. All right. So these are the formulas that you need to know. Do you have the extra one? You can pass the extra one to Sarah. Okay. You didn't bring her.
So extra what?
Huh? Come, just Nick. Okay, so please remind me, where did I stop the last week? Because
you stopped with the first question.
no, it can't be. We didn't 25. Yeah, so 25. I didn't do this last week because. All right, here. There we go. So this one done. Is this done?
Yeah.
Done already.
Wait, I did it.
No.
I'll send it to you.
Yeah, okay. So we go through this one now, right? So I'll just go through a few, and after that you'll be doing the rest. Now this is under physics again, as I mentioned last week. Science has a lot of calculation. You need your calculator. Okay, you need to bring a calculator. As part of science, I know it sounds and it feels a little strange, but that's what it is. From now onwards, right, even for the rest of your secondary school term, your Sec 2, Sec 3, Sec 4, every time you go for science, especially physics and chemistry, you need to bring a calculator, unless you're doing bio. Okay, who wants to do bio next time? Sec 3?
Bio?
Okay, bio no math, no need to bring a calculator. Okay, unless you are in practical. Bio is about human body, animal, plants.
Good. Psychiatrist's job.
Psychiatrist's job. A doctor's job, more like, okay?
Psychiatrist
More like the brain.
I'm probably gonna take bio because
It's all about bio is all about memorizing.
You know, like last year.
You need to take bio for psychiatrist.
Yeah, but it's all about memorizing stuff, right? Then they're talking about physics. Physics is all about math. Physics, math. Right? Chemistry is a mixture of both.
Bio, right? I can't function therapist.
If you want to be a physics therapist, you have to
Physiotherapy.
you have to take bio. That's right. Biology. Okay, cool. Alright, so let's take a look at question 25. Okay, that's your calculator. Okay, so Juliet usually takes 30 minutes to travel to the supermarket at 2.5 kilometers. What should her speed be? If you want to reach the supermarket from her office 10 minutes faster than usual. So let's just, so 10 minutes means instead of 30 minutes becomes 30 minutes, right? 30 minutes, 10 minutes faster. Usually it's 30 minutes. Now 10 minutes faster, so it's 30 minutes. Now to find the speed equals to distance over time. So the distance, you see that this is in kilometers, so we can use this. So this is 2.5. Alright, but this minutes, right?
0.20.
No, I need to convert to hour. 30 minutes is how many hours? 20 over 60. Right? So in your calculator, you gotta take 2.5. Key in 2.5 divided by 1/3. So answer is 7.5 kilometers per hour. Okay, so that answer is 1. So the answer is 1 for this. All right. Okay, so next one. I'll just do a few to jumpstart. All right, next, what happens to the mass and volume of a liquid when it's heated? So when you heat a liquid, what happens to the mass and volume? Does the volume increase? Yes. Right, because liquid, when you heat something, the volume will go up, increase. Right, then how about the mass? Does it become like 2 kilogram, become 3 kilogram? No, so the answer is 3. So no change. Okay, so whatever we're doing here is part of physics. It's about calculation, quantity, formulas.
Physics sucks.
This is physics. Okay, physics is the life is all about physics.
No, it sucks.
Everything that you are doing right now has to do with physics. Okay, next one, question 27. Jason cycles from his house to his school at a constant speed of 15 kilometers per hour. If the distance between his house and his school is 12, how long does it take to reach his school? So how long does it take means what's the time? To find time. Okay, you need to use the DSD triangle. Do you know the DSD triangle?
Yeah, but I forgot everything.
Oh, what is the DSD triangle, Sarah?
Distance,
What is the DSD? Yeah, distance, speed, and time. So in this case, they ask how long does it take. That means we want to find the time. So to find time, you take distance divided by speed. Okay, so what is the distance? 12 kilometers divided by the speed, which is 15. Okay, so what's 12 divided by 15? Where's my calculator? Where is my calculator? Yeah, I get my calculator.
0.8.
So it's 0.8 of an hour. How many seconds is that?
An hour.
What?
Divide by 60 times 60.
Okay, so you see here, last week I actually went through all the calculation, right? Meter per second, kilometer per hour, all this stuff. Okay, so here we go. Now 12 over 15, we get 12 by 15, we get 0.8. So what is the SI unit for this 0.8? I mean, what's the unit? It's hours. But the answers are in seconds. So you need to convert 0.8 hour to second. So 0.8 hour is how many minutes? We times 60. 48. 48 minutes. Okay. How do we know it's 48 minutes? We take this times 60. Okay, we get 48 minutes. Now 48 minutes is how many seconds?
2,280.
How do you get that?
Times 60.
Times 60 again.
You know the letters and the calculation.
What?
The letters.
Yeah, what is it? A, B, C.
2880. Wait, I don't think
Extra
I know it.
design.
I haven't used that at all. Even all the way to university.
Extra design.
Never used. I didn't know. No,
It's a decoration.
I have to use it. Because by the time you go to university, you don't use this anymore. You use the computer. This will be like not that useful.
I want computer, yeah.
Huh?
I want university computer.
Yeah, everybody has a computer, right? By the time you go to U, and all your calculation, homework, everything on computer. So why you need a calculator? Next one. Which instrument would you use to measure the diameter of a thin metal pipe?
I don't know.
Let's ask Sarah. Thin metal pipe? Yeah, thin metal pipe. Metal, yes, metal. Huh? Yeah, Vernier Caliper. Answer is 1. Very good. Question 29. Let's ask Rachel.
This is like a math question.
Yeah.
I told you science is math. Okay, you gotta do a lot of math in science.
You didn't see like this kind of question. I really not to do. I just find the way.
You just find what?
I just like times all the
Yeah, times that, times. Right. Rachel. 2. How do you know this? Formula for density. Can you tell us what's the formula for density? Rachel, what's the formula for density? Hey, can you stop dancing? Keep what? Density equals what? Mass and volume. Okay, so mass is kg, right? So you say 2. Okay, that's great. And then volume is 18 times 10 times 10. So this is correct. Easy? You don't need to calculate out, no, just see the formula. Yeah, right. Just don't choose the wrong one. Next one.
why you must calculate?
Sometimes must calculate. Okay, next one. Ashley, question 30. What's the answer? Ashley, don't laugh at the question. You gotta do this. 30. Let's look at 30. Can you stop dropping your calculator? Yeah.
Next question.
Question 30. Ashley. The density of solid M is 2.5. The density of liquid N is 1. Which of the following correctly shows the position of M in liquid N? M in liquid N. Two. Let me see. So you see, in density, right? In density, what happens is that the higher value will sink, the lower value will float. Okay. Now liquid N is 1, solid M is 2.5, so the solid will sink. This guy will sink. It will sink. All right. So which one shows it sinking? One. There, one. Option 1. Okay. So actually, it's not 2. You say 2. You say 2, right? It's 1. All right. The solid M will sink all the way down. Next one. David. Secretary can type 660 words in the result as a rate. 4. 1980 words per hour. 680 times 3. Yeah.
Times 3.
Right. Next. Oh, we're done. Okay, now come to this Vernier Calipers. Let's label each part. Blossom, have you learned the Vernier Calipers?
I used it before.
Huh? No, asking Blossom. Have you learned the Vernier Calipers yet?
No.
No, not yet. Okay. Sarah, what is A?
I forgot.
External jaw. Wait, we have to memorize all of that.
Yeah.
Oh, that's good.
External jaw. How about B?
External jaw.
What is your favorite?
Can you write the one?
I'll send it right now.
Just memorize.
Vernier scale. And D? Main scale.
My son is tail.
Yeah, E is tail.
Yes, I know.
E is father. Right? I actually like the physics part of science
No, I can get.
because there are only formulas. You don't need to memorize so much stuff. Bio is really painful. Okay. No, bio is painful. For example, let me show you the part of the heart.
Is it to memorize?
Yeah, you're gonna memorize all these.
Yeah.
What? Okay, look at
This is
that.
amazing.
I don't brain.
This just one heart got so many things. Oh.
Every day memorize these.
This sec 3, right? I remember I was sec 3. I was like, what?
Not only memorize.
Yeah, then you must know everything. What's the purpose of every single
No,
Do you
thing.
teach bio?
No, I don't teach this pure bio, okay? Like Sec 1, Sec 2 bio is easy, but this one is like what? Right, and this is only the heart. What about the mouth? Oh my God.
Tongue. And that's it.
Look at that. No, this.
Yeah, okay.
What?
That's correct, the tongue.
There's so many things. Right? And the cell.
Cells.
Part of the cell. No, it's this. Everyone
It's
has
just a
a,
more complicated part of
yeah, everyone has a function, okay? Every single
And then
one.
she can do
See, I know someone, I know psychology, I was very good.
You know the rough.
I remember sucking.
Mitochondria, the what molecule, what
No, you remember I was very good.
yeah, no. So Golgi body, I don't even remember what's Golgi body. Golgi
Also,
okay, so to me it was like a bit too much stuff. Right?
This.
Yeah, that's why when I went JC, I didn't want to do bio because they after you learn the parts, then they must cut down.
You
even
take
more.
your time.
Yeah, I took pure science. Okay. Okay, next. So A, suggest the use of label part A. So what's A used for? To measure what?
external.
Exterior diameter. Okay. B is to okay. Just go through quickly. Right. This is used to measure the exterior diameter of anything. This is the interior diameter. E is to measure the depth. That means how deep, how high or how deep something is. Okay. So that's easy. Next one. All right. Choose the most appropriate instrument to measure each of the following. If you want to measure the duration of a swimmer to complete 2 laps,
Electronics.
somehow
1, 2, 3, 4.
yeah, 0.5 mile.
B only do right.
But internal diameter, Vernier Calipers. 0.1 gram of copper sulfate salt for a chemistry experiment.
Use your eyes.
Beams of balance.
Hmm?
Beam balance.
Beam that 0.1. So electronic. Next one. Time taken to complete a 100-meter race.
Meters.
Yeah, against the mechanical.
Again, he's all.
What's the difference?
Electronic stopwatch is just a normal stopwatch. Mechanical is the old one this time.
What electronic?
Wow, so expensive. $500. What?
Not even worth it.
Electronic?
300.
Oh God.
This is so expensive. All these are like the classic things.
The one that you just the top.
Yeah, digital. I mean, people use this nowadays, right? Only $31, isn't it?
Then I got $10.
Okay. Yeah, the mass of a 50 ml conical flask.
How to measure? You don't need to measure if you think about it. They give you like
Being balance. Okay. So what's the trick here? The trick is every time they say mass must be some kind of balance. Whether you use the beam balance or the electronic balance. Okay, mass, you use balance. You don't use a weighing machine. Okay. All right, next one. All right, about this. Math again. Jessica found that by 20 attempts the maximum. Can you try this?
no.
Do now. We're gonna check everybody's answer. Okay, let me do the calculation here. All right. So Jessica found that by 20 attempts, she could build a small swimming pool. 2 hours and 40 minutes. She also found that she would need twice the time. Okay, how much water was required? So you see 12.5 liters per minute. So 2 hours, 40 minutes. How many minutes? 2 hours, 40 minutes. How many minutes?
180 minutes. 160.
Yeah, I just realized over here they said physics one.
Isn't it 160?
Times 12.
Oh, yeah, yeah. 180.
16.
I didn't even use the calculator for that.
My math is going
Wait.
Let's see physics times.
I'm doing it first. 750. 750 liters. Okay,
Wait,
that's the first one. That's the first one, right? 750 liters. Okay, to fill up the swimming pool. So what was the rate of water flow when the tap was at its minimum? So if it is at its minimum, okay, they say it needs twice the time. Twice the time means is 3 times less flow, right? So you just take 12.5 divided by 3.
Yeah, and then it's 2000.
2000.
Yeah, 750.
160 times 12.
Times 60.
Oh. What is it?
It's 2000. That's confused. What?
2000. Even you did math sum, you got 2000.
No, it's actually.
Oh. Okay, next one. So what's the rate when the tap was at its minimum? So you gotta divide by 3, which means 3. Oh, you got 4 and yeah, good sign. Okay, it's about 4.17. Okay, 4.17 liters per minute. Today is the 17th.
I was 50 tomorrow.
Okay, so that's pretty simple. Next. Yeah, you divide by 3 because minimum is 3. It takes 3 times, twice the amount of time. That means it's a lot decimal. Yeah, not decimal. So we just change to 4.17. Okay, next one. Alright, table shows the density of various matter. So all these different density. Identify the substances. Now, if there's glycerin here, mercury here, P. Okay, can you try this? PQR. Let's start with Sarah. What is A? Yeah. What's A? I mean, what is P? What is P? Glycerin is here. Mercury is here. So what is P? P is all the way down. That means it can sink in mercury.
So it can be anything.
Alcohol.
No,
There's only one thing.
Wood.
Wood will flow.
There's only
Oh,
one
it's
thing.
Yeah, platinum. Okay, next, Jim. What is Q? Q is a liquid, right? So what is Q? Q is less dense than petrol. No, it's less dense than petrol. No, it floats on petrol.
It's alcohol.
Yeah, alcohol. All right, next one. What is liquid R? Rachel? R for Rachel. Ice. Ice. Liquid. Liquid R.
Yeah, water.
Between petrol and glycerin. So petrol is 0.8, glycerin is 1.3. What's between? Sorry?
Glycerin.
The what? Turpentine. 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 Do you know what's turpentine?
No.
Turpentine. Use it when you are doing painting. Okay? You want to thinner or turpentine to remove. It's a flammable liquid that can be used to remove paint. Right, turpentine. Okay, next. Actually, what's S? Liquid S. more dense than turpentine. Liquid S is more dense than turpentine.
Just thinking all the liquid that's in this one.
What?
Like there's only 4 liquids here. And 3 is
I think I can repeat. You can repeat. More dense than turpentine, right? So there's is either glycerin, mercury solid is here.
No, it's
mercury is already on the thing.
Yeah, right. So they help you already, right? Glycerin. Do you know what glycerin
No.
is? Oil, fats, fatty oil. Okay.
why do you need fatty oil?
Some people put it on the skin. Okay.
Why?
It's a skincare product.
Why?
Look at that. Right. ICI power glycerin emollient.
I thought that's just for like.
NTUC.
And it's in medical store,
I
right?
think that's for like wounds.
See, you what? Hey, who's good in Chinese? What?
Something here.
Something here. What?
Noon Fuji, right?
I will do.
Noon Fuji, moisturizer.
Google Translate.
Noon, right? Noon. No, Noon
Google
Fuji
Translate.
is some kind of not to be taken orally, right? It's for external use. It's something like a moisturizer. It helps to look at this. That smoothen the skin for dry skin, chapped skin, especially hands. It's under drugs. All these are called drugs. 美德药行. Ready? See my Chinese A2. What's the first word? Anybody knows?
I think it's you.
Huh?
Google Translate.
甘油啊，甘油，鱼肝油。No. Alright, so that's glycerin. Next. Okay, last one. David, what's T?
Wood.
Wood. You know what's wood?
Yeah.
This
No,
is not wood, no? You know?
It's not, but it's like.
This is cheap box.
Yeah, it's
plastic top, but inside is cheap box. Cardboard. It's cardboard, right? That's why this one is cheap, okay? Because it's not.
Yeah, this is bad quality again.
But it's fine. After 14 years, right? This piece of table right here. If the students haven't vandalized it, it can still last for another 30 years. I see Jane go and dig hole here and
Yeah,
there.
how would I do it?
You've been sitting here for 2 years, right?
Yeah.
Yeah.
I was already.
Yes.
Years ago.
Okay. Next. Okay. Next is finding the area of an irregular object. Okay. How do you find the area of an irregular object? Do you all know? Have you all gone through this before?
Yeah.
Yes.
Irregular.
Yeah, irregular. So what we do is, okay, let me just give you one. Yeah, give you one example, right? So you see this. Okay, I'm gonna zoom in here. All right. So this shaded part covers more than half a box, so we count it as one. This obviously is one. Okay, about this? Is it more than half? This one more than half? Okay, so 4. This one is 5, 6, 7, 8, 9. This one? Is it half or more than half? It's less than half, so we don't count. Okay. Then 11, 12, 13, 14.
Just anyone draw before review.
Okay. That be it's a artistic. What do you call it? Okay, all these are less than half, so we don't count, right? Oh, here, less than 25, 26, 27. Okay, so this will be 27 meters square. All right, so that's how we calculate the area. Okay, can you try for this one? Try. Hey, Rachel, don't.
Yeah, I told you to see the gorilla.
Let me see.
Gorilla came out.
Rachel,
Doing that the whole lesson.
Rachel, do a work, okay? Not that work, right? Do this science work. You not actually tell your mama.
It's too small.
What?
It's like a problem.
Go respect.
It's the first box. It's the first box. Come on, yes.
Yeah, it counts as one. I think it's one.
Alright, so
Watch it. So much quieter and Sarah's not here.
I think he fell into the other bowl.
So if he leaves the French office at 9 and takes 40 minutes to reach the office, so he leave restaurant leave at 9 a.m. here, 40 minutes to reach the office, right? So what is his speed? The speed will be distance over time. So S equals to D over T. Okay, what's the distance? 1.2. So we take 1.2 divided by the time. So time 40 minutes, right? But we gotta convert to hours. So 40 over 60. So you gotta take 1.2 divided by 2/3. So 1.2 divided by 2 over 3.
Oh, it's not raining.
1.8
Oh, I got it wrong.
kilometers per hour. Okay. Distance divided by time. Okay, next. So if he cycle to his house from his office at twice his speed. House, office, twice the speed. So twice the speed will be from here to here. Okay, twice the speed will be 3.6 kilometers per hour. Right? Because this is the one time average speed, twice will be 2.6. So from here to here, you want to find the time, right? What time? Huh? So how to find time? Time means distance divided by speed. So 1.08 divided by 3.6. So 1.08 divided by 3.6. 0.3. Now this is 0.3 hours, which is equal to times 60, 18 minutes. Okay? Huh? Times 60. So you get 18 minutes. Now that's not the final answer because they asked what time will he reach there. So 9:40 a.m.
Why did it time 60?
Because this hour, 0.3 hour. We're gonna find out how many minutes. Right? So the time will be 9:58 a.m. by the time he reached the office. Next, he travels back to the restaurant at which is 10. He reaches the restaurant at 11:58. What's the distance between his house and the French restaurant? What? What's the distance here and here? He then travels back.
But he never tells how long.
He then travels back. What? He reaches the restaurant. So he traveled back. That means now he's here, right? Now he's here.
I think that is home.
No, now he's here. Then he traveled back here. That's continuation from here. Right? You see, he cycled to his office, right?
Yeah, then you see.
At what time? 9:58. So at 9:58 he's here.
It takes 2 hours to go to the restaurant.
So now 9:58 is here. Okay. Then he need to travel back. Now when he's traveling back, now he's traveling at 10 kilometers per hour. Right? Let's verify the story. He reached the restaurant at 10:58. So 10. Wait, is it 10? 11:58, right? 11:58. Okay, so 11:58 he reaches here, so we're gonna remove the original one. All this confuse us, alright? Okay, so if he's traveling at 10 kilometers per hour, how long does it take to cover this? That means the time, distance divided by speed. 1.08 divided by 10. 1.08 divided by 0.108 times 66 minutes and 48 6.48 minutes.
So I 648 years old.
Wait, 6.48 minutes. 0.48 times 60. Okay, I think there's something wrong with it. A bit weird.
Yeah.
How old are you?
No, Sarah, focus on the work. Okay?
He didn't say how old you are anymore.
He then traveled back to the restaurant and reached out. Yeah, he reaches the restaurant at 11:58. Oh. Okay, we didn't have to do this, sorry, this step is extra. Yep. We just have to find the, you see what's the total time it took? 9:58 to 11:58 is 2 hours. So if the time is 2 hours and the speed is 10, what's the distance? Yeah, so distance will be 20 kilometers, right? So here is 1.08. So here must be 20. Take away 1.08. That will give us
Can you just travel back by the 1.2 km?
18.92. That is odd. Okay, but
can you just cycle back from the 1.2 km?
that's the answer.
You need to go to the
Okay.
house,
What's
right?
confusing?
I actually need to go back to his house.
Wait, do you understand what's the problem here? Does it even make sense?
You want to go back to the restaurant, can you just
Yeah,
straight to the restaurant from the office?
yeah.
You need to go back home.
Such a long distance.
It doesn't make sense.
Why would you rather go 20 km when you can just go 1.2? That's some bullshit. Agree.
Okay,
Why you so much fun?
no, I think there's something wrong with the figures, okay? The triangle doesn't make sense, right? You see, if it takes, if it's 1 kilometer here and 1 kilometer here, how come it's 20 kilometers here?
Exactly.
You know what I mean?
And the line is only like a bit longer than 1.0.
Right, something wrong. But it's okay, right? The math works out.
The answer correct.
It should be just like that.
Study when you were here.
Okay. Okay, next one. Jasmine cuts a shade from something he places on a grid to find its area. What is the length L? Oh, sure, working clearly. What is this?
Length L.
1 cm.
L is 1 cm.
Yeah.
Oh, what can I do?
Primary school.
What is the area of this small square? What's the area of one small square?
That's not the big one.
So difficult. Oh
So
my
it's
god.
one,
It's too high.
2 lines.
It's too high. I don't know how to do.
No, but I actually got to
Estimate and calculate the area of the shade. What's the area of the shade?
Yeah.
4 times 3. After 4 times 3. Then that's only at the bottom line.
Estimate, I'll say the estimate.
Estimate is
Yeah.
What's the area of the shade?
Wait
20.
20?